Hello everyone, welcome. So I thought I would make this brief video just to explain a bit further how weighting works, because I've got a couple of questions both in office hours and also in the JIT, and because we didn't have a live class for this explanation, I thought this short video would help understand a bit better. So I thought I would show it just graphically. So the idea here is that we have a sample and we have two groups, z equals 1 and z equals 0. You can think about this in a very broad term. So in the way that we've been seeing it so far, for instance, Z could be a treatment assignment indicator, meaning that this group would be the treatment group and this group would be the control group. But again, you can think about it more broadly, just as being two distinct groups within a sample. So for instance, in the example that we saw today in class, this could be the survey respondents and this could be the people that did not respond to the survey. Okay, and that is basically the example that I'm going to follow in this quick tutorial. So the idea here is that we want to make the group of respondents, z equals 1, look more like the entire sample. So look more like all of this. So as you can see, if we look at z1 and compare it to z0, there are substantial differences in terms of characteristics. In this case, again, this is a toy example, we only have one characteristic, which is color, okay? So z equals 1 in this case, there are much more purple units in the respondent group, and on the other hand, there's much more orange units in the non-respondent group, okay? So that imbalance basically means that my group of respondents doesn't really look that much like the entire sample. The entire sample is fairly divided between orange and purple units, while clearly the respondents, or z equals 1, is dominated by purple units. So let's look at this in numbers. So this is very easy to do, you just have to count in this case. So we have a sample of 20 units, right? And 11 of them, meaning 55% in the entire sample, are purple, and only 9 or 45% are orange. If we just look at the group C1, we can see that 7 of them, meaning 70%, are purple, while only 3 or 30% are orange, okay? So clearly this means that there's an imbalance between my entire sample and my group C1, or my respondents. So what can we do about it? We can actually use weights for this. So we're gonna estimate the probability of being in C1, meaning the probability of being a respondent, and I'm gonna, based on their characteristics, meaning their color, okay? So I'm gonna fit a function of the probability of z equals 1 as a function of their characteristics. In this case, we only have one characteristic, color. If you were doing this with a sample, you could use all the covariates that you think would be helpful to predict the probability of z equals 1. And we're gonna fit a logistic regression in this case, okay? In this case, it's much more straightforward, basically, because we, again, only have one characteristic. But in practice with data, you would fit a logistic regression like we did today in class. So let's do that and calculate the probabilities of being in each group given your color. So basically, if a unit is purple, it has a 7 out of 11 in probability to be in z equal 1, basically because, again, 7 out of the 11 purple units are on this respondent group. While if a unit is orange, it only has 3 out of 9 possibilities of being in the respondent group of z equals 1. Again, because we only have 3 units here out of the 9 total orange units. So those are the probabilities, right? This would be exactly the same probabilities that you would get if you used a logistic regression and used that to predict probabilities based on their characteristics. So now we're going to estimate the weights using the previous predicted probabilities, okay? So now we're just going to focus again on this respondent group, or z equals 1, and we're going to just not think too much about the non-respondent group in this case, okay? Remember that we actually don't have outcomes for this group, so we're not going to be using them except for the construction of the weights, which we already did. So again, we would have this predicted probabilities that we're going to call E, okay? And it's gonna be 7/11 in probability, which is roughly 1.6 for the purple units, and the predicted probabilities for the orange units that are gonna be 1/3. So what do we do with that to construct weights? So the idea here is that we will use the same formula that we use for weights for average treatment effects to try to approximate this respondent group to the total population, or to the total sample in this case. So these are constructed in the following way. The weight is going to be what the z variable over the probability of being in the group c equals 1, which is again that e vector that we saw, plus 1 minus z, whether you're in the group, again, 1 or 0, over 1 minus the probability of being in group z equals 1, okay? So it's easy to see that for units in the group of respondents, z equals 1, this is going to be 0. So again, we don't care about this. We just care about this term here. And the weight is going to be 1 over the probability of being in z equals 1. And this varies depending on your color, okay? So for purple units, remember that E was 7/11. So basically, because it's 1 over 7/11, then this is 11 over 7, and that's 1.6. And then for orange units in z equals 1, the weight now is going to be 1 over 3/9, or the same 9/3, which is 3, okay? So again, see how the more likely units in z equals 1, basically the purple units, receive lower weights than the unlikely units, which are the orange ones, which receive a weight of 3 in this case. So let's see how this looks when we actually use the weights. So now I scaled basically each of these units depending on their weights. So these were scaled by 1.57, and these orange units were scaled by 3. So as you can see, now my orange units are gonna weigh more than actually the purple units, okay? Because again, they were less likely to be in that group. So I need to compensate for that, so that now my respondent group, z equals 1, looks more like the whole sample. So let's look if this is true. We can use weights to estimate the proportion of orange and purple units in z equals 1. So now we're not just gonna estimate the raw proportion in this group, but we're gonna estimate the proportion considering their different weights. So remember that each purple unit now it's gonna be worth 1.57, and each orange unit is gonna be worth 3. So first, let's calculate the total units that we have considering weights. So we have 7 units, which are the purple ones, that weigh 11/7, or 1.57, and we have 3 units that basically are worth 3 units each. And if I add both, we obtain 20, which again makes sense because 20 is the number of total units that I had in my sample. Now let's estimate the percentage of purple units in z equals 1, but considering weights, okay? So now again, I have 7 units. Each of them are worth 1.57, or 11/7, and the proportion of the total is that over 20. So we get that the percentage of purple units in z equals 1, considering weights now, is 11/20. Doing the same thing with the orange units, we can calculate the percentage of orange units using weights. And now we have 3 units. Each of them is worth 3 units, right? The weight, remember that each orange unit was weighed by 3. And we can estimate that over the total weighted amount, which was 20, and we get 9/20. And if you remember, these are basically the same weights with the same proportions that were in the sample. So again, if I consider now each of these units with their respective weights and do any sort of estimation, this sample now, using weights, is going to resemble, at least on observable characteristics, to my whole sample.